go immediately to the first slide. We're getting into it. So, beginning of 2024, I led my first game called Bloodelic. It was a turn-based strategy stealth game where you played as a little goo monster that could walk on walls and was trying to kill everyone within a small town. I worked on it for about 2 months before launching into the production, setting up custom grid tools and basic movement for the character. And I pitched as a game in VG Dev, where the development timeline is around 3.5 months. I was super confident going into it. I thought it was going to be amazing. I was going to get all the features in, and it was a buggy mess. It was terrible. This is, I think, the best video I have of it, if you go to the next slide. This is a very simple gameplay video I recorded, and this is entirely manicured and doesn't show that if you can't actually move as far as it shows. There was a bug that if you only moved one grid cell forward, the game would soft lock. The vision system didn't really work right. It was terribly unoptimized, where if you played on a laptop, you got maybe 10 frames a second. Yeah, you couldn't beat the game. There was no win condition. It just ended when you hit Alt F4. So, the blame for this failure fell entirely on me. There was so much work to go into it, and like the amount of work just seemed to keep growing as I realized all of the systems that went into making a turn-based game, and trying to get everything working by the deadline just wasn't feasible. So, one of the biggest lessons that I learned, that I based my postmortem around, and what I'm basing this talk entirely around, is the necessity of answering the question, what does it require to make a game playable? Not good, not polished, playable. We are talking the most foundational version of this game possible, getting from pure design mechanics to basic gameplay. So this is going to be targeted towards people creating their first game from scratch, students and newcomers being introduced to gameplay programming who may have worked on a few games before, and board veterans. Thank you for your service in the industry. Anyway, next slide. So, I am Jade. I'm a gameplay programmer. My current role is as a mid-levels client C++ engineer on Minecraft Education. I am a former gameplay programmer over at Insomniac Games, where I interned in 2024 and 2025, and then I was a contract associate up until literally last week. I graduated in 2025. I'm a former VG Dev leadership. I actually haven't started my new role. Literally, I am starting on Monday. This past week has been dedicated to driving across the country. Literally, I started a road trip on Monday. I got in Friday night. If there is any explanation as to maybe why some parts of this presentation may be a little bit rough, or if I just stumble over something and realize that I wrote something wrong, blame it on the 50 hours of driving and the 3,000 miles on the road. Thank you. Also, it was my own damn fault. So, anyway, next slide. Going back to the question of what makes a game playable, this is one of the main questions that you have to answer as a gameplay programmer, both in terms of the amount of code required and the amount of time it will take. The amount of time that something will take is an incredibly different question that I'll return to at the end of this talk. And the one that's a little bit easier is the one of the question of code. What is going to be required code-wise? So when you're first making a game, answering that question is the most important thing that you should be doing, as outlining the systems necessary to get your game working in the most bare-bones state is what's going to be required. I'm going to be using another metaphor of building a foundation. The game cannot fundamentally exist without these systems. It's everything that the game will be built on top of. It's not finished by any means, but you at least have the bones of the game. So different games require different foundations, and some games require much more work to get going and to get the most basic version of the game to exist. Minigames also require the same kinds of systems, where even as you're working on completely different genres of games, you're going to be running into these same kinds of systems over and over and over again. So it's good to get to know some of the basics of what you're going to be frequently running into. So finally, a warning before diving in. This is going to be an next slide, sorry. This is going to be an oversimplification of a lot of stuff because we're going to be blowing through. We're going to be ignoring all other disciplines right now. Sorry, artists. Sorry, animators. Sorry, sound designers. My bad. This does not apply to every game, or even within the ones within the same genre that I'm talking about. And finally, this is not to say that one is always easier than the other, or that one is simply better due to mechanical complexity. There's so much that goes into making a game. The programming is just one aspect. Okay, so starting with the one that I generally consider to be the easiest to start with is a 2D platformer. The beauty of a platformer is the centerpiece of your game is also one of the only things that you really need to care about, which is the character movement. And this is where we get into the 3 C's. Go forward. That is camera, character, or controls and character. This is the basics for the majority of all games. Although there some genres place an importance on this more than others, and some aspects may be more important than others, and they're all lumped together because they get interacted with so frequently. 3 C's is something that you might even see on a job app, like a job description of if you're a gameplay programmer, you might only be working within this subgroup of actions. So camera is the viewport into the game world. It's what you're looking at. It's where it's located. It's how it's controlled. It's the rule about how it looks, as in, like, is it boxed by the world? Does it follow the player? Yada, yada. Controls, how the player interacts with the game, mapping and abstracting the actions of the game onto button presses and holds. If you hit A, you jump. If you press left, you move left. And then finally, character, which is the broadest category and kind of encapsulates everything that the character can do, because it includes combat, includes movement and traversal, includes everything. And because all of these are so interconnected, they're generally lumped together. We also have level mechanics. These are the objects and environmental aspects that the player interacts with. Normally, these are one-off, but some can share the same code. It's important when you're creating these to be adaptable, because you might realize code from one thing can be shared with another. So you might want to create a new foundation or to connect 2 of them. For example, in Celeste, you have 2 different platforms. One that if you stand on, it vanishes out from under you. One that if you stand on, it all of a sudden moves. You might want to have a connective piece in order to be able to combine those 2 in terms of detecting the player touching it, and then have actions that come off of that action. So because everything is in like this small, neat package, and you can build out interesting interactions from individual one-off components, platformers are generally the easiest ones to make in such a small time frame, because if you have a level and you are running out of time, you can simply cut the level, and it doesn't actually impact the core of the game. You literally only just need to have the player movement, and then once you have those the other level mechanics, then you just interact with them. It means that generally the game is way more modular. And the more modular your game, the easier it is that if problems come up with a specific mechanic, if you're beginning to hit your deadline, it is way easier to cut and run than to all of a sudden realize we can't finish the game. Additionally, the reason why I call platformers some of the easiest is because a lot of that, like a lot of the things that you're going to need in terms of like player controller, camera movement, all this other stuff, is already implemented in most engines. If you open up like Unity or Unreal, there's already like basic prototypes that is just like a 2D platformer or a 3D platformer. Half of what you need to do is just interfacing with the engine itself. You don't really need to make a lot of things from scratch. Like, you're not going to code the entire physics system if you're already using like a game engine. But you want to create offshoots. For example, like you might want to program your own physics for the character in terms of interaction so it's able to climb up slopes easier. But you might want to just use the basic systems for dropping a rock on their head. And then additionally, it's very important to, next slide, to know about like general resources, because having these plugins at your availability is going to save your ass when it comes to not having to do all of the programming yourself. Looking into like the asset store, stuff like that, finding these pre-made assets and pre-made code packets is going to mean that it's going to offload some of the work that you would have to do from the ground up onto something that already exists, because again, most of this ground is already trodden. Finding these assets is going to be a lifesaver, but it does come with the side effect of it might not be exactly what you're looking for, and you might need to, that requires reading through the code, that requires trying to make some modifications, and you might realize there are some restrictions that you just simply cannot get around. So, next one. So, next genre, first-person shooter. This is where we get into the idea of generalization. Low-key, platformers and some smaller games can be hard-coded to hell. If you just want to have A, always tied to jump, you simply can. However, if you have the idea that you're never going to need to change something, why need to change it? Problem. What if you do? If you change it, well, you're going to have to rework your entire system. It's a bad thing for your entire building to burn down just because you painted the walls. Like, when you're creating these kind of base level systems, something that's very, very important to do is to make it generic, make it generalizable, make it to where there are some assumptions that you are going to have to stand by. For example, you might make the assumption that the y-axis is always going to be up. It's never going to change. The player will always be walking on ground where gravity is going downwards. But when you make it, when you have systems that, by having generic systems, it means that you are limiting the amount of reprogramming that you are going to have to do in the future, saving you time and tech debt when it matters most at the end of the process. I think that might have been, the slide. So next, AI and bots. This is where the difficulty of making a game skyrockets immensely, because generally, everything that a player is not directly controlling has to be controlled by the computer, which means the burden falls on you to make the computer do what you want. Instead of the player walking forward, you now need to have the bot walking forward automatically. And this is where we fall into a whole bunch of different issues. When I was working on Insomniac, I did 3 different roles. I was on hero combat, I was on hero traversal, and I was on AI and bots. AI and bots was by far the hardest thing I worked on, because debugging that required going into and trying to figure out the steps of the computer and not player actions, where in a specific setup, you can manually input that. You have to try to get the bot to do exactly what just happened. That's hard. So we're going to give a very quick example of creating an enemy that walks towards you and attacks you in range. And we're going to break down all the different systems required in order to make that sentence possible. Next one. So, you. The concept of you has to be identified. The enemy has to know that you exist, and that's used through awareness systems. Now, we're just going to say that there is no level of, there's no implication of awareness. This enemy simply knows where you are at all times. Go on. So, walks. Simply the idea of walking is difficult, because that's where you need to have pathfinding. Now, I'm going to break this off into 2 different subcategories, where are you pathing on ground as a single connected surface? As in, are you on a singular plane that you can that has no gaps in between, that has completely walkable surfaces according to how big your enemy is? If so, wonderful. In Unity, you can just use the nav mesh system. That's already integrated. You can do that automatically. You don't need to make pathfinding. Are you doing not that? Congrats! Have fun coding pathfinding from the ground up. That's hard. Especially if you want to move in continuous space. We have entire classes here dedicated to trying to determine nav meshes and calculating nav meshes and walking along them. That's difficult. Next, walks towards you. This is a state or behavior that the bot is then going into, of knowing the position of the player, having been given it, We now need to update their pathfinding in order to look at the nav mesh, figure out the direction to you, and begin to walk in that direction based on the directions given by the pathfinding system. This can be easy, but now next, we need the attacking you part. So these are two entirely different behaviors, the walking towards and the attacking. That means that you need a state machine. Not only do you need a script in order to determine the walking, you need a script in order to determine the attacking. You need something, and you need the transition between the two. That's where the state machine comes in, or to be, when you're within a specific range, switch to the attack and attempt to attack. The second the player exits outside of it, switch back to walking. This is incredibly, this is the most basic that you can get, and honestly, you might want an idle state, you might want a couple other things. There's some issues that come with just this description. But let's say you want a ranged enemy. You're going to have to need more complicated positioning logic in order to try to get it within a certain range, and then look at line of sight. You're going to have to create a line of sight system, which goes back into awareness. Are there stealth mechanics? You're going to need to flesh out the awareness system and try to create vision cones. Again, line of sight. All this other stuff in order to try to go between unaware behavior and aware behavior. Those are two different sets of behaviors. Do you want to have a boss fight? You're going to have to create so many separate behaviors just for that one enemy. There are entire teams and months that go into creating a AAA boss fight that isn't just enemies. Like, that is a whole subcategory unto itself. So this is where the difficulty continues to go up. And then finally, turn-based strategy. The reason I end with this one is because it directly relates back to Bloodelic, and because you are taking so much control out of the player's hands. So UI is always going to be something you need to do. UI programming is something that you, okay, good, I'm good on time, I was worried about it. UI is always going to be something that you are going to have to worry about eventually, but a lot of times it's not directly related to the gameplay itself. Yes, when you have a first-person shooter, you have the HUD, where it's like you have health, you can see ammo, but that doesn't directly impact the gameplay. With a turn-based strategy game, everything is abstracted into menu options, essentially. You now need to start clicking on options and having the player now be a computer-controlled machine. Actions are now so abstracted, it's not direct inputs that you are doing anymore. You need to have the computer step through almost the same processes as it were a bot. So let's say, I don't know why I went all the way back to the beginning. That's so awesome. Yeah, like 2:30. So let's say, like, movement. You click on a specific character, that brings up a HUD in order to show grids around you. You then have to be able to choose onto the different grid, and then that switches over to a new state where now the bot has locked onto that specific grid and is beginning to pathfind towards it. The menu options and the things that you are directly contributing to have to be state machines in themselves in order to be able to choose between it. Save off the grid cell that you just do. Give that to the bot and have them start to walk towards the location. The idea of being able to cancel it right in the middle. Let's say you're in the middle of choosing a grid cell. You don't want to choose. You want to switch over to like attacking or something. That means that you have to exit out within the middle, and you have to allow that to happen and not like leak anything or get the state machine itself confused. Because of all of that, you also have general systemic interaction where all of these systems are now interlocked. Because the player is now a bot, everything that the bot needs to do, everything that would be generally controlled by the computer, now already has to be entirely implemented for the player to be able to do anything. The second you remove one thing where, like, let's say you want to make enemies dumber, you've deleted the entire part of the strategy aspect of it. If you want to try to make pathfinding a little bit easier, well, that now impacts the player experience directly in terms of what they are able to do. all of this gets built up to where having a turn-based game at the end of the day, or like a turn-based strategy game similar to XCOM, becomes incredibly difficult. So this loops back around to Bloodelic. So let me explain to you a bunch of the concepts. So it's a turn-based strategy stealth game. So we're going to need to have awareness. We're going to need to have bots. We're going to need to have them go from unaware to aware behaviors. We're going to need to have line of sight systems in order to be able to detect where the player is, so that there's generally not that. The pathfinding, the player is able to walk on walls. So guess what? You're going to have to, I had to code that from the ground up in order to create a custom grid system that is able to not only encompass the floor, but also encompass the walls, be able to connect those all together automatically, be able to generate within the level naturally, be able to have the player be able to move onto those walls smoothly and navigate those. Trying to create distraction mechanics in order to now have not just the unaware and aware state, but some sort of like investigative state in order to investigate certain distractions, being able to create the items that initialize those distractions. That was the bottle that you saw at the very beginning in order to pick up and throw it in order to go distract an enemy. Being able to walk up and kill them, having all these, again, the awareness system be able to detect what is suspicious behavior versus what isn't. It just all added together where, how could this not have possibly gone wrong? Especially when you only have a 5-month window, and I am the primary programmer. This is the first game I am creating. This was designed to be terrible. Obviously, this isn't something that I knew from the very start, and it's something that I can see in hindsight, but it was never going to work out. And that is why I am trying to give you this presentation, or to ask you to please not follow in my footsteps. Next slide. And something that I completely skipped over, we're actually going to talk about the other disciplines now. Because fun fact, as a gameplay programmer, you aren't just focused on the design of the gameplay itself. You are having to create the implementations and ability for other disciplines to be able to do their job. You know, if you have a bot walking for it, great. You need to have an animation state machine that alternates between the animations that the artists have done. Does a specific action do a sound effect? You're going to have to create the event for it in order for them to be able to hook into it. There's all of the different things that you are having to do on top of just making the gameplay work. So have the actual fact of all the work that is going into what I've just described, and then add on top of that having to help everyone else. You're going to have to create designer-facing tools, all this other stuff. So your time gets pushed even further down. So now, forward again, this is where I talk about Bloodelic, yada yada. Finally, takeaways. How long does coding actually take? I said that I would get back around to this at the very beginning of how long would creating all of these different systems take. Truth is, I have no clue. It is so variable depending on the game, the mechanics, the requirements, the time constraints, the manpower, the creative changes, reworks, engine bugs, hidden tech debt, and so on, that it is impossible to directly predict how long a game is going to take. Look at GTA 6. Man, how long have they been working on that? How much longer will it take? Time boxing is shockingly difficult because, again, you are having to transcribe human actions to a computer and create an entire world within it. You are having to figure out what things may be interpretable to a human, make it interpretable to a computer, and all of the steps that that takes. The idea of seeing is something that obviously we can do, but trying to tell a computer how to see sucks. So my former manager, Adele Laurie, formerly Insomniac, now over at Riot Games, told me, next slide, one of the biggest things that separates programmers beginning their career and senior programmers is the ability to estimate how long a particular task will take, and that is something that only comes from experience with a variety of systems and problems, because it's really difficult. It is one of the most difficult things that you will have to do. And you don't know it until you simply do it. So, what can I tell you? Every distinct mechanic you add means adding to an existing system or creating a new one. That means more work, more time, more interactions you need to account for. Additionally, more things that the game needs to do that's not directly controlled by the player is another thing that the computer needs to do, and therefore you need to do. And finally, every custom thing that you will that needs to be made is something that you will need to make. That may seem simple, but realizing all that is, at least to me, kind of a revelation. So, understanding the systems required can give you the beginnings of a time estimate that then get updated as you continue to work on the game. So finally, break down the systems you need, know the game that you're making, have your design solid. This is just good in general, and there's a reason it's called code architecture. You are trying to build your foundation. Finally, know your barrier to gameplay. How many of the systems that you are planning on making are needed to have the core gameplay loop implemented? There may be some systems that you want that are nice to have that might not be mission critical, so that might be something that you might want to work on later. But at least in terms of the core systems, try to figure out exactly what you are going to need, because having the number of those gives you a better idea of your timeline. Create your tech stack. Again, you don't need to code everything yourself. Plugins and add-ons exist for you to do certain things. Look into them, figure out which ones you might want to use, if any, and get an approximate time estimate on how long it'll take to implement. Because just because something already exists doesn't mean that implementing it is immediate. Generalize your systems for easy building. If all of your walls are load-bearing, one of them getting knocked down is a major problem. You should be able to build dynamically on top of it all with only a few core assumptions built in, so changes don't require constant reworks of all underlying systems. The less you have to interact with your foundation after you've built it, the better. Finally, learn from failure. Doing is the best way to learn. You will set the house on fire sometimes. You will burn down the bridge. But the key to do that is to do it early before you are heading huge projects with large stakes. Do it now, do it early, do it fast. Learn, play with different systems, play with different genres, find out what it takes to create different kinds of games, and you'll begin to notice trends, you'll notice patterns, and you'll get more experience how to program some of these systems from the ground up, that when you're asked to do it again, you're going to be able to do it faster, you're going to be able to do it quicker, you're going to be able to do it better, most importantly. So with that, thank you. Any questions?